Well, hey everybody, it's Mr. Reeves with you one more time. And today I just wanted to introduce you to the idea of equivalent ratios. Equivalent ratios. So, in our previous lesson, we talked about what ratios are, which is a comparison of two quantities, or sometimes we say a comparison of two quantities by division. For example, 4 to 6 is a ratio, or 8 to 12, or 2 to 3. Those are all examples of ratios comparing two numbers. Equivalent ratios, as it says right here, are ratios that simplify to the same value. So, in talking about what ratios are, we also talked about the idea that you can simplify ratios down by factoring out common factors. All right, so if you look at the example they have here, they have 4 to 6 and 8 to 12. Those are two equivalent ratios because they simplify down to 2/3. In fact, let me show you real quickly how that process works. Okay, so I'm going to go ahead and take 4 to 6, and I'm going to write 8 to 12. Now, those are two ratios. Now, I happen to have written them as fractions. Here they have a colon. Remember, you can also use the word 2. So I could write 4 to 6, or I could write 8 to 12. So you can use the word 2, you can use the colon, or you can write it as a fraction. Three different ways to express the same ratios. But when I'm going to simplify them, I like to write them as fractions because you are already familiar with the idea of simplifying fractions. And simplifying a fraction is when you factor out the common factors. In fact, I'm going to go ahead and erase these equal signs here. And I'm going to ask myself, what is a common factor of 4 and 6? And of course, the answer is 2. So I'm going to take that first number 4 and I'm going to divide it by 2 and I'm going to get 2. And then I'm going to take 6 and divide it by 2 and I'm going to get 3. So we can see that 4 to 6 simplifies to 2 to 3. So 4, 6, and 2/3 are equivalent ratios, and 2/3 is the simplified ratio of 4, 6. Now I can do the same thing right here with 8/12, right? But this time, instead of dividing by 2, by the way, I could divide by 2. It is a common factor, but we're looking for something called the GCF, or the greatest common factor, which in this case is going to be 4. And when I do 8 divided by 4, I get 2. And when I do 12 divided by 4, I get 3. And as you can see, these two are the same. So since 4 6 and 8/12 simplify to the same ratio, they are equivalent. So we would say that 4 6, 8/12, and 2/3 are all equivalent. They are equivalent ratios. Okay? All right, now today what I'm going to be asking you to do is to generate some equivalent ratios. Okay, so I've got these pictures that we used in a previous lesson, and I'm going to show you how using pictures you can generate equivalent ratios, and then I'm going to show you how using just numbers you can generate equivalent ratios. So let's start with this one right here. So yesterday when we worked on this problem here, we were asked to what is the ratio of, in this case, black pluses to red hearts. Now, in the unsimplified version, we would simply count. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or another way we did that, we said that's 2 and that's 5, right? And 2 times 5 is 10. So we knew there was a total of 10 pluses there, right? And then there were 3 hearts going across, and there are 5 going down. So that would be 15. So the unsimplified ratio of this picture is 10/15. And the other thing we talked about was if we wanted to get a simplified version, most of the time we could just take a look at this top row here and we can say, okay, Well, I'm going to narrow it down to just the top row. And when I do the top row, I have those numbers right there. I have that ratio of 2 to 3, right? And if we do what I just was doing with you previously, if we took a look at that, if we took 10 over 15, and we said we wanted to simplify that, and we said, what's a common factor? Well, a common factor of 10 and 15 is 5, and 10 divided by 5 is 2, and 15 divided by 5 is 3, and you can see there's my 2/3, right? And 10 to 15, there's my original ratio that I had there. So that is what we did on our previous assignment, and we didn't use the term, but those two were equivalent ratios. But how many equivalent ratios are there? The answer is there's actually infinitely many. There are infinitely many. So I'm going to go ahead and erase what I had done here. And let's take a look at some more some more equivalent ratios that we could come up with. And this is how I'm going to do it. All right, we looked at the whole thing, right? We looked at this whole thing. And when we did the whole thing, we said that was this one right here, 10 to 15, right? And then we looked at just the top row, right? And when we looked at just the top row, we said that was this one right here, okay? But what about instead of the whole thing or just the top row, what if we took 2 rows? Well, if we took 2 rows, and then we counted here, how many of these black pluses do we have? 2, 4, right? We have 4 of those. And how many of the red stars do we have? We have 3, 6. So 4/6 is an equivalent ratio. In fact, we can confirm that because if we divide both of those by 2, what do we get? We get to 2/3. And notice this number we're dividing by here is the number of rows we had here. Very interesting. Well, I bet you know what I'm going to do next. Instead of 2 rows, what if we do 3 rows, right? Well, if I do 3 rows, then what do I have? 2, 4, 6, 3, 6, 9, right? And then if I divide by 3, which is how many rows I grouped, where am I back? I'm right back at 2/3. And of course, you know where this is going to go. I could do the same thing with 4 rows. And if I did 4 rows, what do we have? 2, 4, 6, 8, 3, 6, 9, 12, right? And then we already did the entire thing with 5 rows, okay? So as you can see, you can use the picture. You can use the picture to generate equivalent ratios simply by grouping together any number of rows. Any number of rows from one row to the entire figure. Now, if we wanted all the equivalent ratios, these figures would have to go on forever and ever and ever, which is not a very practical thing to do. So I will never ask you for all the equivalents, but I will ask you for some of them. So let's go back to this one right here. So if we went to, again, to the entire picture right here, that's where we're going to start with the entire picture. All right, how many are there going across of these, what will we call these, white diamonds? 2. How many going down? 5. 1, 2, 3, 4, 5. 2 times 5 is 10, right? So we had 10 here. And then how many of these green pluses do we have? 1, 2, 3, 4, 5, 6, 7 green pluses. And then going down 1, 2, 3, 4, 5. 7 times 5 is 35. So our ratio for the entire picture is 10 to 35, right? Okay, now if I wanted to simplify that, I'm going to go ahead and take this top row here, right? And I'm going to say, now what do I have? Now I have 2, and what do I have here? I have 7, right? So 2 to 7 is my simplified version. That is one row. Now again, if I did 10 35ths, how many rows were there? 1, 2, 3, 4, 5. I took one of them, right? So if I divide this by my common factor of 5, what do I get? I get that 2/7. So this is my simplified ratio. This is my original ratio. And those, again, are called equivalent ratios. All right, but if I wanted more equivalent ratios, what could I do here? I could simply take 2 rows, right? And if I took 2 rows, what do I have? I have 2, 4. And then what do I have here? These come in what? 1, 2, 3, 4, 5, 6, 7. And 7 times 2 is 14, right? So 4/14. Again, if I divided this by the number of rows that I grouped, I'm back at 2/7, right? So 4/14. But I want to put these right next to each other, and I'm going to put an equal sign, okay? And I'm going to start with right here, and I'm going to put 2/7 because that was the most simplified, so that was 1 row. And then 2 rows is 4/14. What about if I do 3 rows? Well, if I do 3 rows, then I have 2, 4, 6. And then I have, how many were here again? This was 7, right? 7, 14, 21. All right. Are you starting to see a pattern when I write these next to each other? All right. What if I do 1 more row after that? Didn't really help me. I think I just could have just start over. All right. Then now this time I'm going to group 4 rows, right? And then what do I have? I have 2, 4, 6, 8, right? And then by 7s, I have 7, 14, 21, 28. And we already did the whole thing, right? When we did the whole thing, what do we have? 2, 4, 6, 8, 10, 12. 7, 14, 21, 28, and 35. All right. So this is not all the equivalent ratios that exist. We could go on forever, but this is all the equivalent ratios that there are in this picture. And I wanted you to see this because take a look across the top. What do we have? 2, 4, 6, 8, right? All right, we missed one, didn't we? Wait a second. My bad. This was 10. See? It's a good thing I'm checking my work here, huh? 2, 4, 6, 8, 10. And then we have 7, 14, 21, 28. And then another 7 is 35, right? So if I were to ask you what the next one would be, even though it's not in the picture, it'd be pretty easy, right? Because what am I going to do? I'm just going to add another 2, right? I would just be adding another 2. Of course, my drawings aren't going to be anywhere near as good as theirs, right? And then what do I have? 2, 4, 6, 8, 10, 12. And then what would the bottom be? I would need to add a number 7. All right, I'm going to cheat here. I'm just going to put plus 1, 2, 3, 4, 5, 6, 7, right? And then what would I have? 35 plus 7 is 42. Right, and if I wanted the next one, I could just add another 2, and what would it be? It would be 14, and if I wanted the next one here, I would just add another 7. It would be 49, and we could do this forever and ever and ever. And those are all examples of equivalent ratios. Again, this one right here is the most simplified because there are no more common factors. This one I could divide by 2. This one I could divide by 3, 4, 5, 6, 7, and so on. All right, you divide by the number of rows you used or the number of times that simplified ratio appears, and it will get you back to the simplified ratio. All right, so real quick, let me just ask you, if I just gave you any given ratio, okay, if I just gave you the ratio of, let's say if I had, 5 to 7, and I asked you to generate equivalent ratios. Well, the easiest thing to do, all right, is just going to be to take that first number and multiply it by 2. 5 times 2 is 10, right? And then I do the same thing to that second number. So my original ratio was 5 to 7. My equivalent ratio is 10 to 14. I simply doubled it, right? What about the next one? Instead of multiplying 5 by 2, I'm going to multiply 5 by 3, right? 15. And 7 times 3 is 21, right? And then I could do it again. 5 times 4 is 20, right? And 7 times 4 is 28. And then we could do it times 5. And then we could do it times 6, right? 7 times 6 is 42. And we just keep going and going and going, right? Just take that first one. All right, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. All right, and then the second one, 7, 14, 21, 28, 35, 42, 49, 56, 63, right? And so on and so on. That is how you can generate equivalent ratios. Okay, so that's what equivalent ratios are. And that's how we can generate and recognize some equivalent ratios. We're going to spend more time in our next lesson on actually recognizing if I just give you two random ratios and ask you, are they equivalent? That's a little bit more challenging, and we're going to save that for our next lesson. All right, I hope this video helped you learn and helped you work through today's lesson. Have a great day, everybody. See ya. Bye.